Hello, good morning. Myself, Chief Engineer Vikas Biswas. Today I will discuss a boiler part 2 regarding the air positioner and the air servo problem. मैं गैस नहीं दे रहा हूँ, मैं रियल कंटेंट दे रहा हूँ जो आपको ऑन बोर्ड काम करने में बहुत बहुत ही हेल्पफुल होने वाला है. ठीक है, एंड दिस विल हेल्प यू फॉर प्रिपेयरिंग फॉर योर एग्जाम as well. Before I move into short job, I wanted to capture all these videos, all the problems that I faced during my tenure on board, and hope this video is going to help you. It will give you enough confidence during your tenure on board. So please try to assimilate this so that it will become a part of your organ and you become confident. So without wasting any more time, let me take you to the real content. Here we go. So let us just know the basic concept of the air positioner. What is a air positioner? The air positioner is an electronic pneumatic positioner consisting of three major parts. What are the three major parts? That is, it has got a IP positioner. The manufacturer is Sippert. You know what is a IP positioner? I means current and P means pressure. This means your current signal is getting converted to pressure signal. Next, pneumatic actuator. There is a pneumatic actuator which is controlling the vents for the FD fan. There is a FD fan, as you know. So this FD fan is providing air to the furnace. So there is a vane. There are some vane at the inlet side. So this is a FD fan. This is the volute casing of the FD fan. Inside this impeller is there, and this is the inlet. As you see, these inlets are shut now because this actuator is in the initial position. It is in zero position. So these vents are shut, so there will be no air intake. So the FD fan will be running, but there will be no air flowing to the boiler furnace. So this is the FD fan, and air is flowing to the boiler furnace or to the wind box through this duct. Next is feedback mechanism. This Sippert IP positioner backside, there is a feedback mechanism. This is basically, there is a linkage and there is a roller which is fitted on this inclined ramp plate. I will discuss this in detail. Now, what we do here, there is a current signal which is coming here, 4 to 20 milliamps. This current signal is getting converted to air signal. This is the input air pressure which is coming from a regulator. This is the fixed pressure, and as per the current signal, it will be converted to air pressure. The more will be the current signal, the more will be the air pressure, and this pressure is going from these two ports. You see, one port, this is a port, and this is another port. This is going to the actuator. This is the actuator. There is a piston inside, and this two port is connected either forward or backward of the piston, and thus the piston moves forward or backward. When this, so sometimes this port is getting activated and sometimes this port is getting activated. Accordingly, this copper line, pneumatic line, which is connected from here, and it is connected to this actuator. So it is actually moving this actuator forward or backward direction. So here the mechanism is linearly proportional. That means the current signal, as per the current signal, the movement of the actuator is getting activated linearly. And this Sippert IP positioner, that is converting a 4 to 20 milliamp signal to air pressure. Generally, this air pressure is measured in PSI. So this is the 4 milliamp signal coming to the CPAT IP positioner, and I have told you these are the pneumatic line which is connected to the forward and backward of the signal. And if I increase the air pressure, you see this is the FD fan vane. FD fan is running inside, and this is the mechanism. These are the roller, and there is a ring fitted which is controlling the inlet vanes of the FD fans. So if I increase the air pressure, if I increase the current signal, it will move the actuator. So let us do that. See, it is 6 milliamps, 8 milliamps, 10 milliamps, 12 milliamps. Now you see the actuator has moved in the forward direction, and there is an angular displacement, and the vanes, the inlet vanes has opened, and it will help to suck the air from engine room, and that air is going to go to the wind box of the boiler. So let us increase more. This is 20 milliamps. This is the largest displacement of the actuator in the forward direction. Same way, and 100% capacity. Now boiler air capacity is 100%. That is the maximum air intake is possible in this position. Now if I reduce this, see, the current signal is getting reduced and the actuator is coming back to its normal position. So this is the 4 milliamps. That means actuator has gone to its normal position, zero position. When the boiler is stopped, there is no requirement for air. So in this position, the actuator is in zero position. Next, now you see how this is converted, the current signal, how it is getting converted to the air pressure. That we want to know. This is very, very interesting, and if you know this properly, most of the problem is going to be solved. This is very basic of the IP positioner. What is inside a IP positioner? So you see, IP positioner basically, let us take a closer view. See, there is a set point. The set point signal 4 to 20 milliamps, whatever signal is coming over here, and this is the actual value, analog to digital. These are the piezoelectric equipments, and these are the 5 ways. So you know what is a piezoelectric equipments? Piezoelectric equipments, there are some matter where you put stress and electricity will be generated due to the stress, and those electricity can be used for controlling some gates. Some ports of a solenoid valve can be opened, closed as per the signal coming. So basically there is a microcontroller inside the CPAT IP positioner. If there is a deviation in the microcontroller uses a 5-way switch procedure to control the piezoelectric valves, which in turn regulate the flow of air into the actuating chamber. So this is the piezoelectric equipment, and according to the set point and what is the desired value, there is a deviation. With the deviation current, this is coming to the piezoelectric equipment, and this piezoelectric equipment is controlling the gate. Let us take the next slide. You can see, so input air pressure is coming from here, and it is going, this port is open now, this is coming here, and consequently this is coming here. It is acting, this is the diaphragm, suppose out of the piston of the actuator, it is coming, it is acting on top of the piston. So this piston will be shifted downward. In other way, if this piezoelectric equipment is getting actuated, it will open this port. In that case, the air pressure would have gone here, it would have come here and acted down below the piston, which will shift the piston upward, in the upward direction. Now you see the microcontroller with the help of the piezoelectric control, how it is controlling the actuator actually. Now you see in the CPAT IP positioner at the back side, this is the feedback mechanism. How the feedback is given? This is rotating either in clockwise or anti-clockwise direction. So feedback mechanism, this gives a signal, the angular signal. Now, when used as a valve positioner for the butterfly valve, it can directly mounted on the hydraulic actuator. Now, this is here, the actuator produces linear movement. This movement needs to be converted to angular. What is happening? This air pressure is coming either to the forward or backward direction, and the actuator moving linearly. But our feedback mechanism gives angular signal. So, this linear movement has to be converted to angular movement. How it is done? This is done. This portion is connected to the linkage, which is connected to a roller. This roller is traveling on a taper plate. So, when it is traveling, the linear movement is getting converted to the angular movement. You see how this is the feedback mechanism. This is the linkage, and this is the roller which is moving on this taper plate. As the actuator will be moving forward, you see it gives the angular movement. See actually how it is. This is the current signal coming here. This is the CPAT IP positioner. This is the feedback mechanism. This is the linkage, and this is the roller. This roller is traveling on top of the taper plate, and thus it will move either in clockwise or anti-clockwise direction. It gives the angular feedback as per the actual position of the actuator. This is the roller. This is the taper plate. So now, how the commissioning or initialization is carried out. The initialization, before initialization is carried out, please take out this CPAT IP positioner from the box, as it will be supplied on board, and there will be instruction. So please follow the instruction before doing it, because there are some programs you have to save those programs in your new this thing as per the boiler or the combustion controller boiler panel. You will get this data, or you can save it from the old IP positioner. Please write it down in your diary, and when you do it, when you replace it, please put the exact value. There are some value it will be asked during the course of the initialization. So what is the zero position? Like it will microcontroller, it will ask what is the zero position, what is the full scale value, what is the direction and positioning speed of the actuator. Next, we will move to the troubleshooting section. This is going to be very, very interesting. Suppose sometime you get a servo air pressure alarm. What is a servo air alarm? Servo air alarm is that when you fire the boiler, there are some sequence and there are some position, the ignition position, then the firing position, then the post purging position. So in this position, your air pressure has to be within the range with the air fuel ratio. If it is deviates more than 10%, it will give you servo air alarm and your boiler may get tripped. So it will lead you to emergency situation. And if the problem, the troubleshooting takes so much time, there will be delay in discharging and ship may be off-fired, and there will be immense pressure from the charterer, from the owner. So as we have seen earlier, the best way to check the operation of the air positioner to give a manual current cell. So this has happened. So you do not know it is the problem, it is an electrical problem or it is a mechanical problem, that we have to establish first. The problem is with the CPAT IP positioner side, or it is the feedback signal, problem with the feedback, or problem with the actuator, or problem with the mechanical controlling of the FD fan vanes. Where is the problem? That exactly we need to know. So how we will need to know? So any problem happens on board, just follow the basic. So you have to divide this problem into parts, and stepwise thinking is required to take decision, wise decision. So suppose there is a problem. So now I want to just understand or identify, is this problem coming from the CPAT IP positioner? So I know that 4 to 20 milliamp signal, this is coming from the combustion controller CPU. Is this a correct signal that I can measure from the CPAT IP positioner input? There are two wire going where I can put my multimeter and I can measure the current signal, and the stop condition, that should be 4 milliamp signal. And if I put it to manual and I give let me show you. First, I will put this thing to manual. There is a button here, hand signal is given. If you press it, keep it pressed for some longer time, it will give you the manual. In this display, you can see MAN, it is showing. So here, 4 milliamps signal now at the initial position. Let me increase this. With the increment of this, you can see this actuator is moving and vents is opening. And you can see here how much percentage it has opened. So in this case, it should open 100%. 100%. The actuator has moved forward and it should open 100%. So if you reduce this means this CPAT IP positioner is working, the signal is going, and the feedback mechanism is also okay. Suppose if you do not get this, then it is somewhere problem. This is the CPAT IP positioner. So the CPAT IP positioner is not functioning correctly. So what is the problem? So now we will differentiate the problem. It is very easy. First, what if we know that the problem is here, what we will do? We know the mechanical part of the FD fan. What are the mechanical part? This is the swivel linkage. The rollers are there. They are moving on a ring. So sometimes the linkage is, due to wear and tear, there is gap inside, or due to dirt, dust, that is going inside, and due to misalignment, vibration, it gets stuck. This linkage gets stuck. This linkage, all these things, they misalignment, due to misalignment. So you have to free those parts, lubricate properly and make it free. When you are confirmed that you have made it free, you connect it, start it again and give the signal, increasing this current signal, put it on manual, increasing current signal, that's it is moving freely or not, and giving you corresponding feedback exactly with respect to the movement of the actuator. So let's see how we do it. So this is the linkage. You can move this linkage. You can put a pipe or something, or by hand you can move in this forward or up direction. You can see this is opening or not freely. That you can know the mechanical parts are okay. Now when you open it, you can give manual, but one thing guys, you have to remember, that is, don't do it when the boiler is in running condition. Just stop the boiler, keep the boiler in stop condition, then you do it. Check the vents for free movement, ease of the vents if required. These are the rollers which are moving on this ring. These are moving on the rings. Then checks for the excess play due to wear down in the moving parts. Excess play you have to ascertain, or you have to renew these parts, this roller. Now put it, remove the cover, then press it and this button, then it will go to manual position. Then with this is plus or minus, you can give signal, like here 12.5. this you can increase or decrease accordingly. This air pressure will be generated and this actuator will move. In this case, when you put it on manual, the control system and bypass mechanism, this control system and the bypass mechanism, feedback mechanism is bypassed. Now pneumatic actuator. If there is a problem with the pneumatic actuator or not, how you are going to know that? Check supply air pressure. There is a regulator, of course. Sometimes there is dust, dirt, and there is an inlet filter which gets clogged, and the air supply will not be sufficient. So you have to understand the correct air pressure is going or not. And there could be leakages because there are many unions connections. Here there is a union connection, here is a union connection. So all the connections you have to check for leakages. If there will be continuous leakage, the air pressure is going to go down and exactly you will not get the proper functioning of the actuator. Check actuator for free movement over complete range. If required, overall the actuator. What happened with the actuator? The air also sometimes is very dirty. There will be moisture inside, there will be lacquer formation, and inside dirt, dust, etc. If it is going inside the actuator, sometimes the piston get jammed inside, or there will be the piston ring, it is a special kind of this thing. If there will be this air bypassing the piston, so this position will not be accurate. There will be hunting, and the actuator will never be stable. It will be moving forward and up direction to attain to its equilibrium position. So main intention, if your feedback is correct, if your input air pressure is correct, there is no leakage, the actuator will attain to its normal position, desired position, and the FD fan vane will open to correspondingly to as per the current signal with respect to the signal from the boiler combustion controller, and exact amount of air will be passed inside the furnace for the proper combustion control. Now, the whether problem is with the feedback mechanism. Sometimes the problem is with the feedback because this gets loose. If this, there is a bolt or nut which is connected here. If this gets loosen up, then what happens? This is moving, the roller is moving, but there will be a slippage. So exactly it will not give the feedback. The feedback will be wrong. In that case also, you will get a wrong reading and everything will be unstable. You will not get the proper air pressure and the boiler may get tripped. Then this roller sometime come out. Roller gets worn out. Roller gets stuck. So you have to check that. There is a spring which is keeping this roller pressed on this taper plate. So spring also play a major role. Sometimes this spring gets dislodged from its original location. Now confirm that the feedback mechanism is not loose or it has not shifted. This is checked by operating the air positioner till the roller mechanism becomes horizontal. At this time, the reading on the display of the positioner should be. So keep this actuator on the horizontal position. The roller mechanisms, when it becomes, you see, the roller mechanism either goes up or down, but sometimes in a position when the actuator moved 50% from its original position, it's become horizontal. So when it is become horizontal, you can see in this display 50%. That's when 50% air is going. That means the actuator has moved halfway in its original direction, that is forward direction. So if it is not like that, this has become horizontal or 50% is not there, this means there is a problem with the feedback. So you have to correct that. Either the roller or the linkage, somewhere it is the problem. If the vanes are working okay when the positioner is manual mode, then suppose positioner is in manual mode, vanes are working okay, everything is okay. So then we have to check the electrical signal. Check the electrical connection, that is the cable carrying 4 to 20 milliamps from the CPU positioner. Sometimes this gets loosened up due to vibration and exact correct signal. Sometimes it is going, sometimes it is not going, and we have faced enough problem like this. So you can take out this, put a multimeter in loop in series. That's mean this terminal has to be taken out. Put the multimeter to measure to the position of the milliamps. Connect the black end with this and connect the red end to this point, and you can measure the current. Then check the PI value. So I have told you there are some values. This is proportional value and integral value. Normally the values P is equal to 0.35 to 0.4 and integral value, that is I int, is equal to 3 to 4 seconds. So this value you have correctly configured or not. During the course of configuration, if you make a mistake, this can happen also. Another thing is that there are two throttle valves, Y1 and Y2, the side of the actuator, where there is a breather valve also. So this throttle valve is very important. So with this throttle valve, we can make this actuator fast acting or slow acting. If we close it fully, the actuator will become very fast. If we open it fully, actuator will become very sluggish. So we have to follow the instruction, and normally they should be open 1/4 to 1/2 turn. These values act as a restrictors. So these valves act as a restrictors. Throttling these valves increases the positioning time of the actuator. So start new initialization of the positioner and then check the operation. If you have air leakages, whether internal air leakages is not, how to ascertain that? Start new initialization of the positioner. When the run 3 is indicated on the display, press the plus, that is the up key. This will start the leakage measurement. Wait until the measurement is displayed. It should be close to 0. Continue initialization by pressing plus and wait until finished. Thank you.